Solving rational equations. We're going to start by solving this rational equation, x plus 6 over 2x plus x plus 24 over 5x is equal to 2. First thing that we want to look for is the least common denominator. And I'm going to put the 2 over 1 just so that they're all fractions to stay consistent. And then we look at all of the denominators that we have, and we try to build our least common denominator from there. Here, what we need to make sure of is that there's a 2 in our least common denominator because there's a 2 in that first denominator. There needs to be a 5 in there because there's a 5 in that second denominator, and it needs to have an x, which is something that they both have. If I multiply those all together, that actually gives me what the least common denominator should be, which for this case is 10x. Then our goal is actually to change the denominator in each of our terms in the equation to 10x, and we're going to do that by multiplication. So we want to figure out what should we multiply each fraction by so that the denominator will be 10x. The first one, if we multiply by 5 over 5, that will give us a 10x. The second one, if we multiply it by 2 over 2, that would give us a 10x in the denominator. And then the last one, since the denominator is a 1, we're going to multiply by 10x over 10x. And then if you verify and just look at what you have in each denominator, just know that if you multiply those together that you will end up with 10x, which is exactly what we want. And then I put parentheses around the numerators because when I go through to multiply, I want to make sure to use the distributive property. And just also as a side note, the reason we're multiplying, for example, by 5 over 5 is that we don't want to change our initial equation because 5 over 5 is equal to 1, but we're just saying whatever we have to multiply the denominator by, to keep it the same, I have to do the same exact thing in the numerator. And now I'm going to multiply everything through. So if I distribute on the top, 5x plus 30, denominator is 10x. Distribute it on the second one, we get 2x plus 48 over 10x, and then if I multiply on the other side we get 20x over 10x. And at this point, the whole reason we were getting the denominators to be the same is to try to simplify the equation that we're solving. And right here, since all the denominators are the same, we can essentially just disregard them, and that's because if we now multiplied everything by 10x, they'd cancel out anyways. But you could also say, in order for the equation to be true, we really just need to figure out when the numerators will be equal, since the denominators are already equal. And the problem that we're solving then is 5x plus 30 plus 2x plus 48 is equal to 20x. And then we can try to combine some like terms. 5x plus 2x, 7x, 30 plus 48, 78, and then we still have 20x on the other side of the equation. Now the equation that we're trying to solve is 7x plus 78 is equal to 20x. And this is a linear equation, so we just try to get the x's grouped together on one side in order to get our final solution. So subtract 7x from both sides, and then you can divide both sides by 13, and once you finish solving, you should end up with x is equal to 6, which is our solution to this equation. If you wanted to verify it, you could actually just plug this value into your original equation. So everywhere in our original equation where we would have a x, we can replace it with a 6, with the original equation being right here what we originally had, x plus 6 over 2x plus x plus 24 over 5x is equal to 2. And the solution is 6.